Some partial differential equations can be solved by direct integration rather than by separation of variables. Let's see how this works with a simple example. We want to solve the equation the mixed partial derivative of u with respect to x and y equals 0 in symbols that is written curly d squared u by curly dx curly dy equals 0. First, we integrate once with respect to x. This gives us curly du by curly dy equals an arbitrary function of y alone. We write this as curly du by curly dy equals f of y. Next, we integrate this result with respect to y. This gives us u of x and y equals an arbitrary function of x plus an arbitrary function of y. We write this as u of x y equals g of x plus h of y. Notice something important here. Every time we directly integrate a partial differential equation, we get an arbitrary function, not just an arbitrary constant. This happens because the equation only tells us how u changes with respect to one variable at a time, so the part depending on the other variable is left completely free. Now let's check our answer. We take our general solution, u of x, y equals g of x plus h of y, and differentiate it with respect to x. Differentiating g of x plus h of y with respect to x, the h of y term vanishes since it does not depend on x. This leaves us with curly du by curly dx equals g prime of x. Now we differentiate this result with respect to y. Since g prime of x does not depend on y, this term also vanishes. This leaves us with curly d squared u by curly dx curly dy equals 0, which matches our original equation exactly. So the solution u of xy equals g of x plus h of y is confirmed correct.